All right, welcome everybody. So, as you know, last night Tesla dropped a brand new demo of its Tesla bot. This time it's a Gen 2 version. We're going to watch a little clip of that, but luckily for everybody, we've got Dr. Scott Walter joining us. We also have Brian White from My Tesla Weekend. He and I have been doing these co-streams. Check out his YouTube channel. But Dr. Scott Walter, he is the expert in robotics. He and I have done many videos now on not only Tesla bot, but many other bots. And he's a founder of two robotic companies. Scott, if you can, please introduce yourself to the folks here.
Yeah, hello, I'm Scott Walter, and a lot of you probably already know me from some of my posts about the Tesla bot over the past year or so, and also a lot of the videos we've done together with Herbert, one of your better performing videos explaining how the Tesla bot actually works. And we now have a new generation, which is going to be very different. And if it seems a little bit noisy behind me, it's because I'm coming to you from Zurich, actually on the Opernplatz by the Zurich Opera, where they have what they call the Christmas market or the Weihnachtsmarkt. So there's a little bit of noise around here and everything and some commotion, but hopefully everyone will enjoy the background because we got quite the early Christmas present today, didn't we? Brian and Herbert.
The early Christmas present. Let's go ahead and watch this minute demo, and then we're going to get your reaction to it because you actually have found a couple nuggets. That's quite interesting.
Okay, so nice little contrast between the two, so we can see the evolution over like that. It's very difficult to have a gripper which is able to do both of those things. So that's considered the ultimate test. And of course, we could see based on this, there's at least two of them. All right, so we know they've been able to make more than one, and I'm assuming it's a lot easier to manufacture these than it was the first generation bot.
I'm going to go ahead and show the evolution first of when these bots came out, and then we're going to go frame by frame. So let's watch this. This is August 2021. They just released this, and they showed a human in a dancing costume saying that they're going to do Tesla bot. And I don't know, I was pretty embarrassed about it. I didn't think they should have done this at all. But the funny thing is now, 2023, this dancing bot, it's looking very close to that original
Very close. Very close. I have to admit, it kind of dances like I do, kind of keeping the feet planted on the ground and not doing a whole lot. So, yeah, I guess that's pretty impressive dancing based on my standard. Not quite the same as the suited up dancer that we had there. But the other things you'll notice is that this version looks a lot closer to the original concept.
Yeah.
You know, because the Gen 1, you're like, whoa, that's strikingly different. Okay, they've got a humanoid bot, but it's not quite what we expected. And then again, looking back in September, they're already showing off what it could do when we were just assuming, oh, they're sticking with this design. This is one they're moving ahead with because look at how much they've been able to do in September. Yet here we go, a couple of months later, they have something. Now, in September, they just didn't decide to pivot and work on this other bot. They've been fine-tuning it for a while, and Elon gave us that hint back in May when he talked about the Tesla-designed actuators. Remember, we were shaking our heads and saying, well, wait a minute, the Gen 1, aren't those the Tesla-designed actuators? And I guess they were kind of designed, but they were probably the early prototypes of what they wanted to have. But what the refined versions, as he was saying, lighter and tighter, was in the works. And they're getting everything ready to go. And look at this, when they came out with it, it's already able to do a lot. Because remember when the Gen bot came out after Bumblebee, the Gen 1 bot, it couldn't do anything. They were like, in a few weeks it'll start walking. So sometimes when you make that leap forward, you also kind of slide back a bit. They didn't slide back. They're moving ahead with that new design.
Well, I'd love for you to compare the Optimus Gen 1, which is March, which is like, what, 9 months ago, to Gen 2. This is Gen 1. And last night, Brian and I with Hans were evaluating this, and we were wondering if the torso had changed. But before you answer that, why don't we go ahead and go clip by clip, and you share every little detail.
It hasn't changed, it's improved. Okay, first thing, so we see the feet and the knees, so I'm covering there, and the hands there. If you look at the hands, you will note so that when we go to the first one, the feet, we're going to see a bit more in the feet. You know, better covering there. So that's already telling you, aha, they're getting it ready to be more, let's say, user-friendly within the environment to make sure things are covered up, that you're not going to be snagging on things. Things aren't going to get in there. You're not going to have the pinch points. So better protection. So that was kind of a hint. And we could also see the quick glimpse from the feet that were down there and the hand. Now that hand, I have seen that hand before, and so have you. And that hand looks an awful lot like the original prototype hand. If you go back to AI Day 1, when they revealed the original one, the hand kind of looked like that. And then they came out with the other versions like, it's not quite like it. So you'll notice there are some design elements that are very similar. So they have definitely evolved this a little bit. And we'll definitely get into it when they start to show what's going on with the hand. So this is the teaser or the trailer for the video itself.
Yeah,
everything that's going on.
The neck. What about the neck there?
Oh yeah, the neck. I mean, it's like, okay, what's that? It's nice. It's the nice mesh. It's kind of covered up there. Is that going to be revealing something that's going on that we weren't expecting? And of course, the very first thing we see when it starts the first movement it does is in the neck before anything else. And as we recall, that's the lighting there might partly be to tell you a little bit about the status that it's in. So if it's like flashing red, that means there's something wrong and need to be fixed, or green that it's operating, or it's in a waiting state. So it might be similar to some like the light trees that you typically see in the factory floor to be able to tell what kind of state that it's in. That might be part of the reason. So it's not just mood lighting and not just that it looks cool, but actually will have some sort of function on the floor to let you know the state that it's in.
Neck movement, Scott, neck movement.
Yes. So the first thing, that's the thing I said, holy cow, the neck moved. And then it's looking at its hands. And I have a couple of theories on why the neck is moving. One of them is it just makes it easier for it to track objects and to really look at it. So they're probably able to see that, sometimes it's out of its field of view. It might be nicer to have that. The other is when they were training it telerobotically, remember the operator was moving his head, but the bot could not.
Yeah.
So the bot was being trained. Well, wait a minute, you're showing me a field of view that does not match what I'm being trained. So they probably realized, we had to put that neck movement back in there. At that point, they probably decided it was easy enough to do. And I have a theory of the actuators they're using. Remember the actuators on the wrist? There was one actuator that actually causes the wrist to do that kind of roll movement. And that's the only place that was being used. And it was a low power, low torque actuator. I'm like, man, that's a lot of effort to design a bespoke actuator for just one movement. All the others are used in more than one place. And I thought, I bet it has enough torque to go in the neck. So they probably have two of the same ones there in the neck. I bet that's what that low torque rotor actuator. Yes.
2 degrees of freedom. The neck.
2 degrees of freedom. They can be stacked easily because it had weird protuberances coming out of it. They're like, what are those things for? Except to be able to stack them together with another one, some kind of combination later on. So that's my suspicion, is that's why they're in there. And of course, the neck looks really nice. It's only 2 degrees of freedom. It still can't do this movement, the back and forth movement, which I jokingly say means it won't be able to do a proper header in soccer. So it will still suck in soccer. But you don't really need that. It's not that important a movement to have. But the other two definitely are. And now the movement here is just incredible. And of course, they decided to do it in the same place they had done it with the other Tesla bots, I think just for reference.
Scott, it says here, actuators, integrated electronics, and harnessing.
Yes.
What does that mean?
Yes. Yeah. So the second thing I noticed, besides that the neck was moving, is like, where did all the cabling and harnesses go? That's why at first I was like, this must be CGI because there's no cables. Someone must be tricking me, and this wasn't actually a Tesla account. So where are all the cables? You will notice a little bit here and there, the cables coming through, routing right around the elbow, around the wrist, but they're not really sticking out like they used to be before. They basically have disappeared. And the reason they disappeared is they integrated them into the actuators. This is something we have mentioned many, many times. My suspicion was they were going to clean it up, and one of the ways of cleaning it up is to make it part of the actuator design. So, sure enough, they listened to me. No, they didn't listen to me. They probably was already in the game plan to go ahead and do something like that. And of course, they've integrated the sensors in there, which was always part of the original design. So there's a couple ways you can make an actuator. You buy a motor, and then you buy some sort of encoders, and you bolt the encoders onto your rotary spindly thing on the motor to measure your position, and now you have an actuator. So the idea is that rather than having it like two things you bolt together, why not just integrate it into the package to begin with, since that's your desire to have some sort of sensoring in your actuator. And that's important because we need to get the position and we need to get the torque information. And so they're getting it straight out of it, and they're making it very compact by doing it. And at the same time, they can figure out, well, wait a minute, we've got power coming into this thing. Why don't we just route the power through this thing out maybe the other end, so when we connect another servo on there, it just piggybacks off of that. So that would be one way of being able to route your harnessing and cabling and from all your power through that without having to have some sort of external cable that's just going to snag and going to be a problem. It also means putting this thing together is going to be a lot easier. The manufacturability, everything will be a lot easier.
Okay, 30% walk speed boost, and then once we see the foot landing, you're going to have a lot to say about this new design foot and the toe.
Look at the heel. Look at the heel. So when you start to go here, notice how the heel is kind of angled to the floor, and it doesn't plop down like it did before, but you'll notice that the heels come down, the foot flattens out, and then it rolls off the toe, and the toe box actually flexes. You'll see that part of the foot stays right there. That is a perfect view right there. Look at that toe box. And they have somewhere in there, I think it's going to be coming right on up, maybe like the frame right after it. It says that it is an articulated toe box, not an actuated toe box, articulated. They also have foot force and torque sensors there, something that myself and the machine, who is on Twitter as well, has argued they would need for good walking to be able to, because you get a lot of data from your feet when they're on the ground that tells you something about what you have to do to balance yourself. And by doing that, it has an idea where the center of pressure is. So it has an idea of how to adjust its balance so it doesn't fall over. So the reason why it's able to squat the way it is really well is it's able to tell, hey, wait a minute, I've got a lot of pressure on my heel and not so much on my toes. I'd like to move that center of pressure a bit more forward, please. And the toe box is not actuated, means there's no motor in there, but it articulates. It just means it's able to rotate or move, and they probably have a compliance joint in there, some sort of torsion spring that is able to give the spring back when it does that. Now, that's energy that is returned as it starts to finish its stride. So that actually helps the walking efficiency a lot.
Scott, what do you think about the 30% walk speed boost? So first of all, they've confirmed that everything we're watching here is not CGI. I don't know how many people are saying it's CGI. It looks so good that people think it's CGI. And two, they're saying that it's been sped up, and they have confirmed that what we're watching is, not been changed at all.
Exactly. It's 1-to-1. It's real time speed, and so you can see that its walking speed is about a nice leisurely walking pace. It's not slower than a human would walk normally. It would be nice to maybe be a tad bit faster, but it's really close to what they need to be able to work on the floor. And the 30% boost in speed, I think they're getting that just from improvement in the gait. And there's probably still a little bit more that they'll be able to get out of that. And they're doing it without expending more power. So that's my guess. It's just the 30% improvement does not mean 30% more power. It might be the same power. And a lot of it is coming from the fact that they reduced the weight. So somewhere in there, I don't know if we passed that point already, it went on a 10 kilogram diet. I'd like to ask them if they did keto, because that seems to be, a pretty, 10 kilograms, 22 pounds.
How did this happen?
Maybe in 6 months.
Instead of metal, they're using plastic as one option. What do you think?
Yeah. So I guess, and is plastic like to be? I wonder if it's vegetable based, because that way it would have been a keto diet. I suspect so. I mean, because there's a lot of advantages by losing that mass, especially in the lower extremities there. That means it's a lot easier for you to articulate your leg. It moves quicker because you don't have as much mass to throw around. So that's another place that they could be getting at 30% savings, as well as the manufacturability. Now, the only concern I have is the plastic going to be durable enough to handle the hinge points that are there, right? Because you have a lot of cycling going on, and you have to be concerned about cycling fatigue. I don't think there's a loading problem there. I don't think It's that the plastic is going to be carrying a really, really heavy load all the time. It should be able to handle that pretty well. It's just going to be the repetitive motion of those actuators where it's connected to that piece of plastic, and whether they fortified it in such a way, or what kind of plastic are they using to make sure, it's probably some sort of really rigid, hard polyurethane that they've been able to concoct that's going to work. So it's possible. The other thing is they've probably designed it in such a way that the other parts of, let's say, the bone design that they have there is designed to handle the stresses so well, it's not going to cause any fatigue. So they've got the topology down to be able to come up with the loading as would be expected, and to make sure it's not going to induce or create any fractures or fissures where you don't want them.
Yeah. That calf is very strong. Thank you, Johnny. Yep, absolutely true.
Yep.
It can do this, Scott. Okay, this part, Scott. Whoa.
Yes. Okay. So now what we can see there, and again, is if we go back to it, it's 11. It's a new 11 degree of freedom hand. So the old hand was also 11 degrees of freedom. So let's not confuse articulated, actuated with degrees of freedom. So I believe there's still 6 actuators, 2 for the thumb, and then 1 for each finger, for a total of 6 in each hand. The actuators are actually located in the palm, using tendons to pretty much close the fingers, and probably torsion springs in the knuckles to open them up. Now, it seems to be the same finger design. They're all the same length, and you have only 2 knuckles. You don't have 3 knuckles like on a human hand. So they are using the springs to allow the hand to open up, and then the servos make it clasp down. So that's the opening and closing. Now, they may have changed a little bit, that I've noticed that when the hand opens up, the fingers spread out a little bit, but I think that's just kind of the way they've designed it. It's not that they have the ability to spread the hand. So it cannot do live long and prosper, okay? That's just not going to be something it can do. So when it opens it up, its fingers seem to open up like that rather than staying this way. And because it doesn't have that control, it can't play the piano. But it can do a lot of other things, like maybe iron your clothes and fold your laundry. We'll see. So the hands have been designed to be improved. I think Hans pointed out that it looks like the shape on the palm, where it used to be kind of arched a little bit, they may have straightened that out. So the fingertips almost all have the same length. I'm not sure why they decided to change that. Maybe it was just a packaging issue of how to get the actuators in there. They decided to go with that. But the big thing, before we even go there, if we just go back, hold that for a second, right where we were for a second, is the wrist itself, because that's connected to the hand. They did not change the wrist design. So as far as I can tell, the way all the kinematics works has not changed. The shoulder is still three axes, 3 serial joints that are connected the same way as before. It's just lighter and tighter and well disguised. The elbow, we can't really see how the elbow mechanism works, but I think it's the same as always. It's just been well covered up, and we get the fabric covering that. And then if you look at the wrist, it is exposed, and it's the same wrist mechanism. But they changed it a little bit, because the old ones, both those actuators were parallel to each other. Now, if you notice, they're kind of slanted, they're angled in. And that angling in has allowed them to make it where the wrist is a little bit more narrow. So that was jutting out a little bit before, the connection bar that they would use at the elbow or at the wrist. And now they've been able to make it a little bit closer together by kind of making the servos angle out a little bit more. So that's a little change that they've made. The ankle mechanism is also the same. That basically hasn't changed. It looks different. It hasn't changed. And then when we get to the pelvis is kinematically the same. It just looks different because they changed the pelvic girdle a little bit. And it looks like they reduced some weight there in the pelvic girdle.
It's
so that's
so much smaller, yeah. Scott. It is so much
yes,
smaller. Remember the other bots that we looked at? They're massive.
Yes.
They're like Princess Leia buns. These guys are like,
yes.
I think they're just almost like, I thought maybe they could be the same as the shoulders, but it is a little bit bigger than the shoulders.
They might be different actuators, but let's say they're stacked the way they were before. So you had 3 sets of 2. And they're kind of set up the same way, and they have kind of what looks like the pelvic girdle in the back. It looked like an upside down heart, and it looks like it's still the same for the back. It's just that it's missing everything that used to be there in the front. They decided they didn't need that. they were able to design it with less material. So that could have also been, 1 kilogram right there in mass that they got rid of, just redesigning that a little bit. And then if we look at what they're doing here with the hands, this is what is definitely new, and that is the touch sensing. So again, the idea of picking up an egg is something which has always been a problem in robotics, and now you're doing it, and they're able to do it because they have touch sensing. But look at the heat map. Look at how the heat map moves around there on that touch sensor. Now, I don't know if they have touch sensing only on the fingertips, if it's also in the middle of the fingers, or if those are just non-slip pads that they put there for when they grasp anything else. But clearly, they now have the sensory data coming from the tips to allow them to do something like this and other things. And I think one of those other things that Elon has mentioned is they expect to be able to thread a needle at some point with these hands. So that's remarkable. Now, as you look at the different frames, you will see how that heat map moves around. And notice how the intensity of the heat map changes, and notice that its position on those tips is able to move around a little bit. So that means they're sensing all around the tips. It's not just, oh, I feel something, I don't feel something. It's not a binary on-off. It seems like they're getting a lot of information about the locality of what it is you're touching and the amount of pressure it's applying at that point. This is why after I looked at that, I posted that with these tips, Optimus can probably read Braille. And I didn't get much pushback from that, so most of the people kind of agree. Now, the true test, what we call the James Dalma test, is whether Optimus can count change in its pocket if it was wearing a pair of pants. Something we humans can do, right? If you put coins in your pocket and you put your hand in there, you can count the number of coins you have, obviously, and you can tell whether you're grasping a quarter or a nickel or a dime. There's just enough sensory information you can get from that. I don't know if Optimus could do that trick yet. Maybe. We'll see.
Well, my thing is, I don't, I'm only from the shoulders up, so why would I wear pants in the first place? The bot's got me beat on that front. So I have a couple
That's
thoughts
talking
on
heads
this.
here. Yep.
I have a couple thoughts. The head, could it also be for balance? Could the motion be for balance?
Could be. I don't know how much I think it's kind of got a hollow head. I don't want to insult Optimus very much. I'm not sure how much is in there or how much mass, because obviously they'd like to reduce the mass. But you're right. When you see like a duck walking or something like that, it's using its head sometimes to get the balance that it needs. And if we look at the squatting position when it goes down there, it probably throws its head forward just a little bit to help in that. The other is, remember I said that was one butt you didn't want to see in seats? Well, that new butt, maybe you do want to see in seats. And if it can move its head forward, maybe it could actually get into the Cybertruck. I'm not sure about a Model 3. Probably the back of an X.
Remember we talked about before that the Optimus Gen 1, the head was empty. And in fact, it just had this metal bar that allowed you to be able to grab it and hold it and hoist it up. Now look at this. This is the Easter egg you've been waiting for, and it's right here. Oh, boom. Oops. Gosh. Sorry, guys. Oh, where is it now?
Slow boom.
Where is it? Did I lose it?
Worf is saying that the head is just a decoy.
What does that mean? Right there,
I
Scott.
mean that. Yeah.
Look at this.
Oh yeah. Oh,
so it's being held now at the back. Scott.
Yes. So they probably have something to support it from the back, because before they were hanging it from the head because it would straight to the torso without going to the actuators. Now you're going to be compromising the actuators. So they're probably supporting it some different way when they need to have it on a harness. Exactly. So it may be that, I don't know if they filled it up with anything. They obviously have cameras in there. I would assume they have whatever they need for the electronics for the LEDs that are on there. Eventually, maybe some sort of display screen, and then some sort of audio. But that doesn't take up a whole lot of space or a whole lot of mass.
No, less than a phone.
Yep.
The cams, the actuators on the wrist still appear quite large. Do we think those are going to miniaturize a bit?
They may be. And see, what they managed to do is by angling it, I think they're getting it out of the way of the hand a bit better. So the fact that they've made it kind of a V coming on down there has helped a little bit. And whether they can get that tighter in there, I don't know. But it is definitely an improvement. Definitely an improvement. And the legs do not seem to be as cumbersome as before. So the calf muscles also seem to be a little bit tighter.
Scott, take a look at this little clip here and watch the movement of the bot, right? So first of all, of course, it's beautiful the way it's looking at his hands, but then the way it shifts its neck and the shoulders, is that coded or did it learn this on its own? So take a look at this, right? So it's standing, it's looking, see that little shift right there?
Yeah. I think that's just it's kind of learning that from the overall control system of how to maintain its balance. So it's probably, its main thing it's trying to do is it's trying to make sure I don't fall over, so stay up. And so it's learning how to balance, and a lot of it is knowing where the center of gravity is and keeping it in the right position. So that information is coming in, and anytime you move your body, you are feeling it somewhere else. So even though you think you get your feet planted, if you start moving your arms around and doing something like that, your legs kind of have to respond to be able to make sure you kind of keep your balance. And it's a very subtle kind of movement. So the entire movement of the Optimus bot is definitely combined together into one algorithm. Doing that heuristically is very difficult to do. So it sort of understands what happens when it moves one part of its body. There's going to be a reaction somewhere else that it needs to take care of, which is why it probably was able to squat. And one of the questions I had about that squatting is, was it taught that? Was it shown that? Or did it just sort of figure it out that as it tries to go down and do that, it's losing its balance, and the only way to keep itself from losing the balance is to put its arms forward. So it's maybe figuring that out itself. That could be like an emergent behavior that comes from whatever control system they're using to make sure I don't fall over.
Wow.
So a question I had for you, Scott, is yesterday when Herbert and I were watching it, we noticed that the fingers are straight apart from the ring finger, which is just maybe a 3/8 of an inch shorter. We assume that's for some kind of improved dexterity. How could, you can see it right there, how would that work? How would having one finger a hair shorter add dexterity? Okay, that's what's hard to tell. Are they all the same length, or is it again the offset? Because before they did it by cut, they are all the same length. Did they offset one of them to make one of them stick out a little bit more? Because that's how they did it before. That's all they did. Is along the palm, they made it like a little bit of an arc. And without a really good close-up, it's kind of hard to tell.
Yeah.
They almost look like they're the same.
Mm-hmm.
And part of that length could also be that one of them is slightly bent. So if it's deflected a little bit, it may come up a little bit different.
Boy.
Scott, why don't you explain this bit right here? So you think that because the bot actually has the Tesla logo on it.
Yeah, it just that when I saw that, I said, "Wait a minute! They decided to start branding this thing. They didn't put the logo on the other bots. Now the closest they got with Gen 1 is they put the belt buckle. Oh, that was really nice, but they didn't have it on there, even though the initial prototype did. So you remember, the proposal 2 years ago, that one kind of had it emblazoned on there, and that's what everyone was expecting. So when the Gen 1 came out, it's like, why haven't they bothered to put it on there? It's because they're too busy taking care of everything else with the bot. Let's not worry about getting the stencils out and putting the logo on there or designing it for that. So now that it's sort of showing up, makes me wonder if that is saying, yeah, we're really happy with this design and we're going to go with it for now. Still going to be tweaking. I'm sure they've already got the Gen 3 design on the board somewhere, thinking about what they're going to do next. But they're probably really quite happy with what they have now. And they're at a state that rather than playing around in the lab and gathering data in the lab, it's time to get it out into the real world. and start collecting real world data. And in that case, what I mean, the real world data within the factory, seeing how much manufacturing it's able to do on the factory floor. And then from there, you can start to iterate. But at some point, you have to freeze your design and say, all right, let's check it out. Let's get the information. And if it turns out this isn't a good design, we'll make it better. But they're really close. They're going to be changing some things, but I think there's a lot of the stuff they're going to stick with.
This looks
it looks
really
like they
good,
did not, they did not radically change any of the kinematics. So one possibility is they could have come up with a completely new shoulder. They didn't. I think they stuck with the same elbow. They didn't put a rotary joint in the elbow like all the other bots that we've seen out there. So they're sticking with that. So whatever data they have, they're saying this is the way to go. This is the right way to design the elbow from what they're concerned with. And the wrist, they like the wrist. They say, yep, we're going with that. So everything's been refined. Nothing's really been changed.
Well, let's go through the list here. So this is the original Gen 1. Sorry, Brian. Go ahead.
Oh, it's all right. I was just going to say that I think the movements are so refined that honestly, the current dancing bot is better than the human dancing bot. Not as energetic, but more refined.
Yeah.
Honestly.
Yeah. Yeah.
So Scott, let's go look at this and compare what we're seeing from the Gen 1 to Gen 2 in 9 months. You were saying that they're reusing it, but everything's been refined. But like you said, the big one is cables are no longer out there.
Yep.
It's so much thinner. The batteries are in the middle, right? So it looks great.
It's still. I think it's still the same. It's probably similar torso. They may have made some refinements there. I'm assuming it's the same number of batteries, the same type of batteries.
But look at the legs. The legs was massive with lots of stuff going on here, and that's gone. Oh, I don't have a photo of that.
They had a lot of other controllers that were kind of sitting out there, all kinds of different lights. It's
and then the feet
massively improved.
Metal, and then now no longer flat metal.
Now a real foot. Now something we can call a foot.
There.
And now
and
this,
then of course, the hands.
Yeah.
Oh, we just lost him.
Okay.
He's coming back.
Maybe he's back.
Everyone else, we've seen a lot of walking bots out there recently. You know, everyone has shown their walking bots, and their walking bots are flips, but it may not be able to give you the refinement that you need to do what the Tesla bot wants to do.
This last scene here, Scott, I know that they always do this, but you know they did it in front of a bunch of Cybertrucks, and then now they did it. Do you think this is happening in Hawthorne? Some people are thinking, some people in Fremont. Where is this? Oh, we just lost them again.
Hawthorne. No, that would be SpaceX, right? No, it's probably Palo Alto. I'm assuming it's Palo Alto or in Fremont. So the design team is up in Palo Alto. And I don't know how much engineering goes up in Palo Alto regarding the rest of the vehicles. Obviously, manufacturing is in Fremont. Whether they have engineering down there in Fremont, I don't know. So it seems to be the same area for doing this. I don't think it's Texas. You know,
it is not.
It
doesn't look like Texas.
Yeah, I don't think it's Texas at all. So it's one of the two Northern California locations. And if that's Fremont, which I mean, where would they be? So you have the Cybertruck mules that are going out there doing a lot of testing on. Do you think that's being done in Palo Alto? Or is that being done in Fremont? Because I think we were seeing a lot of them driving around Palo Alto ahead of time, correct?
Yeah. This building from the windows. So I'm not sure where it is.
Now,
if anybody in the comments has a thought, let us know.
This is an interesting building. I wonder if this is a place for employees to come work out and relax, or were that something they specially set up for Optimus? Because check it out.
Right.
It's an exercise studio. It's got exercise balls. It has dumbbells.
And what the bot doesn't need dumbbells. Oh, and maybe to measure how much it can carry.
Maybe for practicing, you get the exercise
while carrying a load.
Exercise balls to sit on, to first learn to sit down and to squat without falling down. Maybe to catch. Maybe they're throwing the balls, kicking the balls at it, and seeing how good its balance is. That's the one thing Tesla has not shown us, is they have not shown us the balance test that everyone else has, where they abuse the bot. Not
I
happening
mean, this
here.
just looks like a demo of, look, I'm looking like a human. I mean, I'm exercising.
Yeah.
It's like similar to when they did this. Oh, look, I can do yoga. I
Yep.
don't know.
Yep.
That's maybe
So
reading a
maybe
little too much into this.
I'm just wondering if that's just maybe it is someplace within the Tesla factory that they have set up for employees that just want to go and work out during lunch or something like that. And they said,
What's
"Oh,
back
that's
here,
a good
guys?
place to test it."
What's back here, guys? Come on, Brian, take a look at this. What's back there?
Well, what do you mean, the semi?
The semi,
What-
the
back
semi.
where?
Yeah,
What is it?
yeah. I noticed the semi was there. I was kind of wondering if that was just coincidental or they're trying to tell us something.
Wait,
That's decoration.
Just decoration. Yep.
Decoration. I know we're trying to find anything we can in a 1 minute
They do
clip,
this.
but
Yeah. They do drop little Easter eggs, right, Scott? I mean, there's been a
We are
bunch that
finding
you
them.
found.
Right. And these are literally Easter eggs there, showing picking them up because that's what all roboticists want to do. The only question is when are they going to be ready to scale up to like 100, 500, and 1,000? Whether that's going to be soon or whether they're going to take their time.
a question I have for you, Scott, is what's going on with the knees? Are those just decorative covers? Do these have knees, or are they just hinged joints?
I think those are just covers. So I think that's just sort of a cover for the mechanism that's going on down there, just to make sure it doesn't get caught into anything. Again, to prevent any sort of pinch points. So the mechanism is in behind there, and that's just a cover.
All right. Okay.
Scott, what's the most impressive? There's the hands, right? The articulation of the hands being able to do things like this. There's the sensing and the fingers. That's brand new. There's the toe off. Anything else that you saw here that was very, very impressive, or just the overall reduction in line? This is now production ready, isn't it? And so it's ready to go.
Oh yeah, I mean there's so much refinement. I mean, so what's the algorithm? Remember the last step of the algorithm? Isn't it something about optimization?
I don't know what you mean.
Is it?
Yeah. So when Elon talks about that, know what your requirements are, right? That's what you start with. Make sure the requirements are less stupid, and you go all the way down it. And the very last one is like optimize. Once you get everything ready, once you're sure with it, optimizing. And they've made a lot of optimizations here. One of them is they've finally figured out how to get rid of the cables. And everyone was worried about the cables early on. I was like, no, don't worry about the cables early on. That's the least of your problems. You've got all these others to solve. Then when you're happy with it, you can start thinking about how to remove the cables. The other thing that's part of the algorithm is remove as many parts until you have to start putting new ones back in. Well, remember, one of the parts they took out was any sort of tactile sensors on the hands. Now they put them back in because they've realized, we took out too many parts. So they've started to put a few back in. The foot, again, they didn't wait to optimize. They didn't optimize the foot too early. They said, wait a minute, we've got to learn to be able to walk and do all these other things, take care of those problems. So you keep on going down it. And again, the last step of the optimization is like slap a logo on it. That's like a part you don't need early on, right?
Right. The first bunch of T-bots, the first, 799 may not have been ready for prime time, but the T800 looks ready to go out there and kill.
Yeah, exactly. Exactly.
You're feeding the queue, dude.
Oh, I'm sorry. I misspoke.
I think honestly, Scott, when you made this post, I know it sounds silly, but look, there's a Tesla logo on it. I honestly agree with you. This is a big deal. The fact that they put the logo there, just like you said, why bother doing that if they're not ready for this to be at least much further down the line than still a beta, still sitting in the lab. This is ready. This is a signal. And then remember at the last quarterly earnings call, it was previous to that, Elon said that, we think we'll have the actuators, Tesla designed actuators, ready for scale. He said ready for scale by November. So now it's December. If everything's going along the right path here, these are now ready for scale. This means that we're no longer, right, they're going to build this in numbers, maybe 1,000, whatever number, right?
I agree. It's ready for scale because it's designed for scale.
Nice.
If we're right, if those components that used to be aluminum are now been replaced with some kind of plastic, wow, I mean, that's going to be really quick to build these things. It also means the cost of these things goes down.
Where are all the cameras? Because it's using the FSD chip, so which is designed for 7, 8, 9 cameras. Where are? I mean, obviously you could put a pair in the head. Where do we have more?
No, they showed 6 before. So when we had the teleoperator back in, I think it was the shareholder meeting when they showed the picking of the parts by human and then the picking of the parts by the robot. He was wearing the actual, I guess you could say, camera suite of Optimus on his head, and there were 6 cameras there. So there were 2 where your eyes are, 2 kind of where your ears would be, and 2 that were looking down. The original Tesla bot design showed that there would be 8, and there were actually going to be cameras in the chest itself to give a little bit more. So I'm not seeing that there. I think they just went with 6, and it's just looking through that black glass seems to be where they're mounted.
Somebody says there's 8 cameras. Optimus has 8 plus cameras.
I'm not sure it has 8. The original design showed 8, but if you look at what came out on one of the previous videos, it only showed 6.
Han says the pelvic girdle on the back looks like a black piece of stamped metal. How do I see
Could
the
be,
back?
yeah.
Where's the back?
It's really hard to see the back. The hardest part to see was the pelvic area because there wasn't any good close-ups, and it was all black. So it became extremely difficult to really be able to see any detail. So the little glimpses are, it looks like there's been an improvement to the design of the pelvic area to lighten it up and to make those motors a little bit smaller. But I can't really assess much more detail than that.
All right.
Okay, Scott. So this is amazing. Pretty well ready for work, right? You've been saying that
Yes.
even the version 1 could already be in a factory. Now, can these bots help create bots? Does it matter that the bots are creating bots? Not right now, right? That's like a future thing, isn't it?
Well,
But
yeah, they'll probably be part. They could be part of the final assembly. There's obviously going to be lots of components that are going to be manufactured the old-fashioned way. And then when you get enough of those components, at some point, those components have to be assembled together. And in those steps that you're typically seeing being done by humans right now, that means Optimus could start doing it. And I certainly think that the final assembly of putting all the arms and limbs and torsos and everything together, that's something that could eventually be done. If they're not already thinking about that, that's always a possibility.
are you expecting Grok to be part of the bot so you can actually speak to it and it can speak back to you?
Maybe someone actually Grok that today. They asked Grok, "Are you thinking of going inside of Optimus?" And Grok goes, "No, I'm not planning on going in there. Optimus, that's all for him. He'll be too sassy and witty for my humor." So they'd have to tone Grok down. So I guess Grok is not looking forward to going into Optimus. But yeah, I think a large language model makes sense to eventually get in there. And as we know, Grok just makes stuff up anyways. So I wouldn't trust anything Grok says.
What's this? It's a little bit of a cable sticking out or something like that.
Yep.
See this?
Yep.
What's that?
Yep. Yeah, that's a little cable that's going to pop out every now and then, just like your veins kind of come to the surface every now and then and disappear, or your a tendon here and there. You're going to see that. And just a warning, I'm on 15% battery, so at any point I could end up like going. Boop.
We're good.
Just
We're good. Okay.
Just to
Well,
warn
first
you.
of all,
Yep.
yeah. Thank you so much, Scott. I know that you're on your vacation, but you told me I can call you up. I tried to wake you up while it was 3 a.m. your time, but you didn't wake up, dude.
Yeah. Well, that's because my phone was smart and it was in night mode. It actually works.
Well, now that I have your wife's info, I'll get you next time.
Yeah.
Thank you, Scott.
Yeah.
Appreciate your
Yep.
advice. This was brilliant. Appreciate everybody. Thank you, Brian. That was
Okay.
great. Appreciate you guys.
Yep.
See everybody.
Thank you. Bye now.